Okay, hello you tens. It's like 1 a.m. in the morning. No, it's not really 1 a.m., but it is early. I want to get this video up for you so that you can have some success with volume calculations for composite solids. So we're going to do this one. I've got a picture here. It's a rectangular prism on the bottom, and it's a cylinder on the top. So, and we're going to find the volume. Oh, that pen is too thick. Let's change all this. Change. Let's make that skinnier. There we go. All right. Going to have a big V, and everything else will be normal size. Right, volume. Now we need two volume formulas because we've got two shapes here. And they're always kind of like this. We need the volume of a rectangular prism. I'm just going to call it R for rectangle. It's the length times the width times the height. That's not very good times. Let's go and just fix that. Let's do that again. That's L for length. I'll space this out a bit better. Width times the height. There's no unit on this, but I'm going to say it's all in meters. Okay. And we need the volume of a cylinder. I'm going to call that volume C for cylinder. Now, it's a prism, and what I mean by that is I'll get rid of this in a second. Actually, I'm just going to draw this for you. A prism means it's got the same shape at one end. That's meant to be a circle, like that. So like a Pringles can. And a prism, you can kind of, if you got a knife and you cut it anywhere, let's say we cut it just there. A prism means that if we cut it just here, that the shape that we cut through is the same as that shape and that shape. So it's called a cross section. A cross section. And that's how you know it's a prism. This means it is a prism. And it doesn't matter the shape. It could be like a triangular prism. So a triangle at one end. Whoops. Blah, 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 blah. You get the idea. My drawing's bad. I'm going to get rid of this in a second. That would have a, I'll try and make that line a bit straighter. That makes it clearer. And that would have a triangle in the middle if we cut it there. And we could have a rectangular prism or a square prism. We could really have any shaped prism. We could have a hexagon prism. Let's see if I can draw a hexagon. I'm trying to make it look 3D-ish, but the point is, the reason I'm going through this is because prisms have a very easy way to figure out the volume. So what you do is you find the area of the end of whatever shape you've got. So you find that area. So it's always area of the cross section, area cross section, multiplied by how long it is, the length. And that's the same for every prism. So you know, area of this one, area of this one, area of this one, multiplied by how long it is. So they're always the same format for prisms. Now, if it's not the same shape the whole way through, that's a different thing. If it's a what am I trying to say here? If it is, what do I want? Oh, no, I don't want that. I just want to select all of that. Delete. I'll delete. Here we go. I'll just wait for that for a second, actually. So if it's a pyramid or a cone or something else, some funny kind of shape that's different at one end, different at the other end, then you can't use the prism. For prisms, if they've got the same shape the whole way through, they always work the same way. Right. So now I can get rid of this. So I've got some working out area. Delete. Well, this is a slow way to delete. I don't know how to select it all. Ooh, get rid of all this. What's the biggest one I can do? Yeah, that's way better. All right, I'll get rid of that. So that's how you do prism. So we're going to do the volume of a cylinder. Go back to black. Okay, volume of a cylinder. So the shape we've got on the end is a circle. So the area of a circle is pi multiplied by the radius square. That's the circle multiplied by, it's kind of standing up, so I'm going to call it the height. All right, and that's this distance here. So let's do this to start. We've got length. We're going to call the length 7, just here. The depth, the height is 4. Length and width is just 2 sides. We're just going to go 7 times 5 times 4 is equal. I can do this one in my head. 7 times 5 is 35 times 4 is 30 times. It must be 140. Did I get that right? Yes, it's 140. That's 140 meters cubed, because that is the units for that's the units for volume. It's got to be whatever measurement we have cubed. Right. This one here, we're going to have to use the calculator. I can't do this in my head, so I'm just going to leave it as pi for right now. I'll deal with this in a second. Times the radius squared. So the radius is 3. So it's 3 squared times the height. The height is also 3, so it's another 3. Now I'm just going to give myself a mini thing here so I can figure this out. 3 squared is 9 times another 3, that's 27. So we've got the answer here is 27 times pi. That's the exact answer, but I want a decimal so I can just get my calculator out here. Well, actually, I'll do it on the screen. Here we go. I'll use this one. Let's get rid of. I'll pop this over here for a minute, and let's quit out of here. Quit. Okay, and let's clear all that. I don't need that. Right. Clear. Okay. 27 times pi. It's so small on my screen, I have to find it. Where's pi? Is it hidden under something else that's on my screen? There it is. Second function, this button. All right, enter. 84.82. Right, I'll go back to here. 84. Actually, I'm going to check the rounding there. Yeah, the next digit was 3, so I can 84.82 meters cubed. All right, so the total volume. So I'm going to do it different. Why won't they get rid of that? I don't want that. I want to say V for volume. V. There we go. That's better. And we want to go V total. I'm going to do T for total is 140, which is the bottom bit, plus 84.82, which is the cylinder on top. And this is equal to, I can do this in my head, 224.82 meters cubed. That's the volume for that combination of solids.